Question 1, which of these is the equation of a straight line? So all straight lines can be written in the form y equals mx plus c. So the only one of these four which is in that form is y equals x minus 6. So that's the only one that's a straight line. Question 2, what is 0.28 as a fraction of 0.8? So the first thing to do is to write this as a fraction. So 0.28 over 0.8. If we multiply top and bottom by 100, that gives us 28 over 80. We can see that these are both even numbers now. So let's half top and bottom, which will give 14 over 40. But we can do the same thing again, which will give us 7 over 20. And that is our answer. Note that if we'd spotted that 28 and 80 are both multiples of 4, we could have divided top and bottom by 4 straight away. We'd have got the same answer. Question 3. Circle the calculation that increases 240 by 7.5%. So we need to work out what 7.5% is as a decimal. So remember that 1 is equal to 100%. So dividing these three by 10, 0.1 must be 10%. So 0.01 must be equal to 1%. As we've got 7 there, we need to have that 7 in the hundredths column, just like our 1 for the 1% there. Well, only one of those answers has got 7 in the hundredths column, so it must be 240 times 1.075. Notice that the 7 and the 5 are still together, just like they are in 7.5%. Question 4, circle the reason why the triangles are congruent. Well, we've got two right-angled triangles here. Both of these have got the 9.2 opposite the right angle, so they're the hypotenuse, and they've also got an extra side, the 5.3. So our answer is RHS, because we've got right angle, hypotenuse, and a side. Question 5, work out 80 million divided by 200, giving your answer in standard form. Both of these have got plenty of zeros on the end, so let's cancel out 2 of those zeros for both of them. So we've now got 800,000 divided by 2. This is a nice easy one. We're just going to divide that 8. So that gives us 400,000. We've now got 4 followed by 5 zeros. So this must be 4 times 10 to the power of 5. Remember, for standard form, that first digit has to be between 1 and 10. Hence, it's 4, not 0.4 or anything like that. Question 6a. Work out 3 to the power of 12 divided by 3 to the power of 7, giving the answer as a whole number. So using our laws of indices, we know that if we divide power by a power, then those powers are going to subtract. So 12 minus 7 gives us 5. So this is 3 to the power of 5, but we need this as a whole number. So let's write out our multiples of 3. We know we've got 3, times that by 3 is 9, times that by 3 is 27, times that by 3 is 81, times it by 3 again is 243. So there's our answer. For part B, we need to simplify 8 times 2 to the 6 times 2 to the 4, giving our answer as a power of 2. So we should be able to spot quite quickly here that 8 is a power of 2. So let's rewrite that out as 2 cubed, there's our 8, times by 2 to the 6 times by 2 to the 4. Well, if we're multiplying numbers together with the same base, we add the powers. So 3 add 6 add 4 is 13. So our answer is 2 to the power of 13. Question 7. In a group of 98 students, 25 study both art and French, 10 study art but do not study French, 41 study French. Joel draws this Venn diagram to represent the information. So he's got the group of 98 students, is his total set. A is the students who study art, and F is the students who study French. We need to mark 2 criticisms of his diagram. Well, first thing we can see is that he hasn't labelled the circles. He's forgotten to put the A and the F on there to tell us which is which. Also, if we add together the numbers on his Venn diagram, we can see that they don't equal 98, which is the group of students. That's what they should total. So he's made a mistake there as well. Question 8. In a week, Samir is paid a basic hourly rate for the first 30 hours worked and an overtime hourly rate for any extra hours worked. The graph shows his pay for working up to 40 hours in a week. We need to work out the ratio of basic hourly rate the overtime hourly rate, giving our answer in its simplest form. So first of all, let's work out what the two rates are. Looking at our graph, we're just going to pick a point along the basic hourly rate part of the line, so the less steep bit. I'm going to go right for the end. This is usually best practice when we're working out gradients, when we're working out things like that from a graph, because it gives us the longest line to work with. So I've drawn a line up from 30. After 30 hours, it gets paid £450. So the basic hourly rate is 450 divided by 30. So that's 45 divided by 3, which is 15. The overtime rate, I'm going to put another line here for 40. After 40 hours, you get £700. But we've got to be careful here, because 30 of those hours were the basic rate and 450 of the pounds were the basic rate. So the overtime hourly rate is our 700 minus 450, which is 250, divided by the 40 minus the 30, which is 10. 250 divided by 10 is 25. So we've now got the ratio of basic to overtime of 15 to 25, but we need it in its simplest form. Both of those are multiples of 5, so dividing 3 by 5 gives us 3 to 5. Question 9a. In each box, write a fraction less than 1 to make a correct calculation. So we've got two fractions multiplying together to give us 3/10. When we're multiplying fractions, we multiply the numerators and we multiply the denominators. So we need two numerators that will multiply together to give 3, so 1 and 3. And we need two denominators that will multiply together to give us 10. I've gone with 2 and 5. We've just got to be careful which way round we put these now, because we need our fractions to be less than 1. So if we put the 2 under the 3, that would be too big. So we do it the other way round. So we have a half times 3/5 equals 3/10. Note that for these, you could have had negative fractions, so minus a half times minus 3/5, because they're both less than 1. You could have had fractions such as minus 1 over minus 2. That would also have been fine. For part B, in each box, write a decimal less than 1 to make a correct calculation. So we need two numbers that are going to multiply together to give 6. So we could have 1 and 6, we could have 2 and 3. I'm going to go with 2 and 3. And because that 6 is in the hundredths column, our two numbers both need to be in the tenths column, because if we multiply a tenth by a tenth, we get a hundredth. And because our decimals need to be less than 1, we can't have some things like 2 times 0.03, for example. So 0.2 times 0.3 or 0.1 times 0.6 would both be great answers. Question 10. ABCD represents a garden. A tree is to be planted in the garden. The tree will be in the region that is closer to AB than to BC. We need to label the region R, where the tree could be planted, and show all our construction lines. So we're looking for a point that is closer to one line than it is to another, and those two lines are joining in an angle at B. So this means we're going to need to do an angle bisector coming out of B to split the angle ABC in half. So to do that, we put our compasses on the point B, so sharp end on B, we draw an arc crossing AB, and without changing the size of the compasses, we also do an arc crossing BC. We then move our compass point up to our first arc and draw an arc in the middle of the shape where we think the line is going to go. Then again, without changing the size of the compasses, we put the point on our second arc, the one on BC, and draw another arc in the middle, which will cross that third arc there. Once we've got that, we just do a straight line with our ruler coming from B through our cross up to the end of the shape. So that's our angle bisector. The tree needs to be closer to AB, so it's going to be in the region to the left of that line, which we can label with an R. Question 11. Here are two shapes, P and Q. P is 3/4 of a circle of radius 20 centimetres. Q is 1/3 of a circle of radius 15 centimetres. How many times bigger is the area of P than the area of Q? We must show our working. So let's work out the areas of these two circles. So we'll start with P. P is 3/4 of a circle of radius 20. Remember, the formula for the area of a circle is pi r squared. So this one is going to be 3/4 times pi times the radius squared, 20 squared. Well, 20 squared is 400. 3/4 of that is 300. So the area is 300 pi. For Q, again, we're going to use the same formula. So now we're going to have 1/3 times pi times the radius of 15 squared. 15 squared is a little bit trickier. That's 225. 1/3 of that is 75. So the area is 75 pi. So to work out how many times bigger, we're going to do our 300 pi divided by 75 pi. Well, we can ignore the pi's there because they'll cancel out. 300 divided by 75 is 4. And that's our answer. Question 12. In a game, 2 bags A and B contain cards. Each card is marked yes or no. The table shows the number of each type of card in the bags. In the game, a player picks one card at random from each bag. The cards are then put back into the bags. For part A, we need to complete the tree diagram. So looking at the first split there for bag A, we've got the yes branch going up to the top, no branch going down to the bottom. So we need the probabilities of yes and no from this bag. If we look back to our table, in bag A there are 3 yeses and 2 nos. So that's 5 cards altogether. 3 out of the 5 are yes, so 3/5 goes there. 2 out of 5 are no, so we have 2/5 on the bottom branch. We can now move on to our second branches. So this is bag B. So for bag B, there is 1 yes and 9 no's. So that gives us 10 cards. Probability of yes is 1 out of 10, and the probability of no is 9 out of 10. Now, what's picked in bag A doesn't affect bag B. So the branch at the bottom is going to be exactly the same as the top. We're going to have 1/10 and 9/10. For part B, to win a prize, a player must pick 2 cards marked yes. 450 people each play the game once. How many people are expected to win a prize? So the first thing to do is to work out the probability of winning a prize. So picking 2 cards marked yes, the only way we can do that is if we get yes from bag A and yes from bag B. So the probability of this is 3/5 times 1/10. If we look at our tree diagram, they're the probabilities for the yes paths. Multiplying them together gives us 3/50. So the expected number of people is going to be our probability of 3/50 multiplied by the number of people, which is 450. 450 divided by 50 is 9, times by 3 gives us 27 people. For question 13, we need to solve 2w over 15 equals 4/5. Now looking at these, as 5 goes into 15, we could make 4/5 into a fraction over 15 and solve like that. That's a perfectly good method. What I've done instead is I'm going to multiply both sides by 15. So the left-hand side becomes 2w. The right-hand side, 4/5 of 15 is 12. So we get 2w equals 12. So w is equal to 6. Question 14. 15 workers can complete a job in 8 days. How many more workers are needed to complete the job in 6 days? Assume that all of the workers work at the same rate. So first thing to do with a question like this is to break it down into unit values. So we've got 15 workers completing a job in 8 days. As we're changing the days, let's work out how many workers are going to be needed to complete this in 1 day. So doing it in 1 day, that's 1/8 of the time. So we need to work 8 times as fast. So we need 8 times as many workers. So 8 times 15 is 120 workers to get this done in 1 day. To convert this into 6 days, that's 6 times as long. So they're going to do a sixth of the work. So 120 divided by 6 means you would need 20 workers to complete it in 6 days. Now this is where you need to be careful. So the question says how many more workers are needed. We've got 15 to start with. We need 20. So 20 minus 15 is 5. Question 15. The cross-section of a prism has n sides. We need to circle the expression for the number of faces of the prism. So if we think about how a prism is constructed, the cross-section is the n-sided polygon at each end of the prism. For each of these polygons, each side is connected to the same side on the other polygon by a face. So we're going to have as many faces going around the polygon, going around the prism, as we've got sides on the polygon, and we've got the two polygons themselves. So the number of faces is going to be n plus 2. Question 16, we need to circle the letter of the possible sketch graph of y equals x cubed minus 4. So the x cubed graphs, they're the ones they start in the bottom left corner. They have a positive gradient before then going flat for a little while and then heading back to a positive gradient to head up to the top right corner. So we can immediately rule out B and C. They're quadratic, so maybe to the power of 4 graphs. So it's got to be A or D, but because it's x cubed minus 4, it would have to cross the y-axis at minus 4, hence it must be A. Question 17, 75 people attend a clinic. Their ages are recorded and a cumulative frequency diagram is drawn. A nurse makes a statement about the ages of the people at the clinic. He says more than twice as many people are in their 60s as in their 50s. Is he correct? We need to tick a box for yes or no and show the working to support our answer. So the first thing we need to do is to get some values from our cumulative frequency diagram, remembering that because it's cumulative frequency, if we take a value off here, this is going to tell us how many people are at that age and below. So if we want to work out how many people are in their 50s, we're going to start by working out where 50 is on the graph. So drawing up from 50 and across, we can see that we get a value of 13. So this means there are 13 people of 50 years or younger. We're now going to do the same for 60. So going up and across, there are 30 people at the 60 mark. And then finally, for the 70s, we go up from 70, there are 66 people. So as our cumulative frequency gets to 13 for 50 years and then up to 30 by the time it gets to 60, that means the number of people in their 50s are 30 minus 13, which gives us 17. And the number of people in their 60s are our value for 70-year-olds, so 66, minus the 30 from the 60-year-olds, which is 36. We're comparing the people in their 60s to the people in their 50s. Well, 36 is larger than 2 times 17, so it's more than twice as many people. Hence, we need to make sure we tick the yes box. For question 18, we're given that 12x cubed plus 7x squared plus 3x minus 10 is identical to two lots of open brackets ax cubed plus x squared plus 2x minus 5, close brackets, plus x lots of bx plus c. We need to work out the values of a, b and c. So the first thing we're going to do is to simplify that right-hand side and bring our like terms together. So by expanding the brackets, we get that the right-hand side becomes 2ax cubed plus 2x squared plus 4x minus 10 plus bx squared plus cx. So now if we collect our like terms together, well, the 2ax cubed, that's the only place that x cubed appears, so we keep that there. But now we've got 2 plus b, lots of x squared, we've got 4 plus c, lots of x, and we've still got that minus 10 on the end. We can now match this up with the left-hand side. So we know that for the x cubeds, 12 must equal 2a, so a equals 6. For the x squareds, 7 on the left must equal 2 plus b on the right, giving us b equals 5. And for the x's, the 3 on the left must equal the 4 plus c on the right, so c is equal to minus 1. So there's our answers, 6, 5 and minus 1. Question 19. The first three terms of a sequence are x, y, and xy, and the sequence is continued by multiplying the previous two terms. For part A, we need to circle the fifth term of the sequence. So let's continue our sequence at the top there. The fourth term must be y, which is the second term, times by the xy, which is the third term, which would give us xy squared. To get the fifth term, we then need to multiply this by xy, which gives us x squared or y cubed. There's our answer. Now for part B, the eighth term of the sequence is x to the power of 8, y to the power of 13. The value of this term is negative. What does this mean about the values of x and y? So we need to decide if they must be positive, must be negative, or could be either. So let's start with the x. We've got x to the power of 8, so it's an even power. So remember, if we raise something to an even power, if it's positive, obviously it's going to remain positive. If it's negative, that even power means the negatives cancel out and it will become positive as well. So our x to the power of 8 is going to be positive, whatever the x is going to be, which means x could be either. But then if x to the 8 is positive, and we need to multiply this by y to the 13 to get a negative number, then y to the 13 must be negative, and the only way we can get y to an odd power to be negative is if y itself is a negative number. Question 20, rearrange y equals 5x plus 9 over x to make x the subject. So here's our equation. To start with, we're going to get rid of that fraction by multiplying both sides by x, which gives us xy equals 5x plus 9. To make x the subject, we need x in just one place. So to work towards that, we're going to subtract 5x from both sides, giving us xy minus 5x equals 9. So now the x's are all on the same side. And to make this into just one x appearing in our equation, we're going to factorise it out from that left-hand side. So we get x times y minus 5 is equal to 9. Now we've got that x by itself, we need to get rid of everything else that's on the left. It's multiplying the bracket, so if we divide everything by that bracket, we're going to get x equals 9 over y minus 5. Question 21, 5 points are connected by vectors, and we're told that the vector fg is equal to 2 times eh. And we need to work out fe in terms of a and b. So looking at the diagram there, fe, we can get that if we can do fg and ge. Well, we know what eg is, so that's going to be fine. So we need to work out fg. But we're told in the question that fg is equal to 2 times eh. So let's start by working out that eh. So eh is going to be ed plus dh. We can see that on the diagram. We're given those, so that's 3a plus b plus a plus 6b, which gives us 4a plus 7b. fg is twice this, so that must be 8a plus 14b. We can now work out fe. So fe is going to be fg plus ge, but as we're given eg the other way round, instead of adding ge, we're going to subtract eg. Using what we've worked out, we now know that this is going to be 8a plus 14b minus the 2a plus 15b from our diagram, which simplifying gives us 6a minus b. Question 22, work out 0.68 recurring minus 0.45 recurring, giving our answer as a fraction in its simplest form. Now, there are a couple of ways to approach this. We could work out the two decimals as fractions first, then do some fraction subtraction. I'm going to bring the decimals together first, however. So we've got 0.68 recurring minus 0.45 recurring. If we subtract them, we can see that the 6 minus the 4 in the tenths column is going to give us a 2. Then all the columns after that are going to be an 8 minus the 5 from the second number, so we'll get a 3 recurring. So far we've got 0.23 recurring, which we need to convert into a fraction. So remembering our method for doing this, if we let x equal 0.2333, so on, we're going to multiply by the power of 10. That is the same as the number of repeated digits. So there's only one digit repeating here, the 3, which means we're going to multiply by 10. So 10x is equal to 2.3 recurring. If we now do a bit of subtraction, 10x minus x is 9x. And if we subtract the right-hand side, 2.3 recurring, we've got 2 take away 0 in the units column, so 2. In the tenths, we've got 3 take away 2, which is 1. Then all of the other columns, we've got 3 take away 3. They're going to cancel out, so we get that 9x is equal to 2.1. Hence, x is equal to 2.1 over 9. But we don't want a decimal in our fraction, so the quickest way to get rid of a decimal is to multiply it by 10. So timesing top and bottom by 10, this must be equal to 21 over 90. We're now just going to check if we can simplify this at all. Well, they're both multiples of 3. So dividing top and bottom by 3, we get 7 over 30, which can't be simplified any further. Question 23. On the grid, Identify the region represented by x larger than 3 and y larger than 1 and x plus y smaller than or equal to 7. So to do this, we're going to draw the lines which match up with our inequalities but as equations. So x equals 3 is going to be a straight line coming straight up through the 3 on the x-axis, like this. Now I've drawn it as a dotted line because our region is strictly larger than 3. We're going to do the same with the y now. So y equals 1 is a straight line coming through 1 on the y-axis. And again, as our inequality is strictly larger than, I've done a dotted line. Now we need to draw x plus y equals 7. So you think of this as just finding coordinates. This is going to go through the point 0, 7, because 0 add 7 is 7. And it's going to go through the point 7, 0. So it's basically a straight line joining up the 7s on each axis. Now, as this one is smaller than or equal to 7, I've drawn it as a full line. We now need to find the region. It's larger than 3 for the x's, so it's got to be to the right of our x equals 3 line. Y is larger than 1, so it's got to be above our y equals 1 line. And as x plus y is smaller than or equal to 7, it's got to be below our x plus y equals 7 line, so bottom left of it. Which means it must be this triangle in the middle here, which I've labelled R. 24a, simplify fully 6 over a minus 11 over 4a. So to do some fraction subtraction, we need to make the denominators the same. They're both multiples of a on the bottom. So if we multiply top and bottom of the first fraction by 4, we get 24 over 4a. We're now taking away 11 over 4a, and as they've got the same denominator, we just take away the tops, giving us an answer of 13 over 4a. For part B, we need to simplify fully y squared minus 3y times by y squared plus 10y plus 21 all over y squared minus 9. Let's look at what we can do with these different parts separately now. So the brackets at the beginning, y squared minus 3y, we can factorise a y out of that to give us y times y minus 3. Quadratic on the top of the fraction, y squared plus 10y plus 21. We're going to see if we can factorise this now. So we need two numbers that will multiply to make 21 and will add to make 10. Not too bad here because there aren't many things that multiply to make 21. We can see that that's 3 and 7. So this must be equal to y plus 3 times y plus 7. And on the bottom, we've got y squared minus 9. Well, y squared and 9 are both squares. So we've got a difference of 2 squares here, which if we remember, difference of 2 squares, we've got the two brackets, the plus and the minus. So y squared minus 9 is equal to y plus 3 times y minus 3. We're now going to put all these back together as they were. So our original expression now becomes y times y minus 3 times y plus 3, y plus 7, all over y plus 3, y minus 3. Well, we can see straight away that the y plus 3's on our fraction are going to cancel each other out. Also, we're multiplying by y minus 3 on the left there, and there's a y minus 3 on the bottom of the fraction, so they're also going to cancel out, which just leaves us with the y multiplied by the y plus 7, an answer of y times y plus 7. Note that if we expanded this, y squared plus 7y would also be a correct answer. Question 25. Here is the speed-time graph for a 50-second journey. For part A, we need to circle the acceleration in meters per second squared halfway through the journey. So halfway through the journey is when the time is 25, so that's halfway along the horizontal line at the top there. At that point, as it's a straight line, the speed is constant, hence the acceleration is 0. For part B, we need to work out the total distance travelled. So on a speed-time graph, the total distance travelled is equal to the area under the graph. The graph is a trapezium shape, so we can use our formula for a trapezium to work this out. So it's half times by the two parallel sides added together. So the top parallel side is 30. The bottom one, going from 0 to 50 there, is 50. And that's all multiplied by the perpendicular height of the trapezium, which in this case is 20, as the top speed is 20. This is 40 times by 20, which gives us an answer of 800 metres. Question 26. Zoe and Amy are playing a board game. They each have one disc and take turns to roll a fair ordinary dice. The player moves their disc clockwise, the number of spaces shown on the dice, and the winner is the first player whose disc is on home at the end of a turn. Here is the board after Amy's turn. We need to work out the probability that Zoe wins within her next 2 turns. So to start with, let's list all the events that would cause Zoe to win this game. So either she could roll a 3 on her next go. This would land her on home straight away. She would win. She could roll a 1 followed by a 2, or she could roll a 2 followed by a 1. We also just need to double check, can she get all the way round the circle and back to home in 2 turns? No, the circle's got 12 parts to it, so in 2 turns the best she could do is get back to where she started. So the only winning things she can do in 2 turns are these 3 that we've listed. Let's work out the probabilities of these now. So the probability, rolling a 3, that's an ordinary dice, so 1/6. Probability of 1 followed by a 2, well, these 2 events separately are a 1/6. So to get 1 followed by the other one, we multiply, which gives us 1/36. And in exactly the same way, the probability of 2 followed by 1 is also a 1/6 times a 1/6, which is 1/36. So the probability that one of these happens, we're now going to add them together. So a 1/6, add a 36th, add a 36th. We can do this if we converted that first fraction to 6/36. We can now add the tops together to give us 8/36, which simplifies to 2/9. Question 27, the grid shows the graph of y equals f of x. On the grid, we need to draw the graph of y equals minus f of x. So all that's happening here is that for any x, we would calculate f of x, match it up to y on the first graph. But now we're going to calculate that same f of x, and we're going to take the negative value. So now any positive values of y will become negative, any negatives will become positive. So all we're going to do is reflect this graph in the x-axis, so it's going to look like this. Question 28, we need to work out the value of cos 30 times sine 45 times tan 60, all squared. Now, if you've remembered the values of these, that's great. You can just put them down, jump straight into the question. I'm going to show you a little trick now just for remembering them, just in case you've forgotten, and that is to draw these quick triangles. First one is if you draw a right-angled isosceles triangle, where the perpendicular sides are 1. Because it's an isosceles with the right angle there, the other 2 angles are going to be 45 degrees. By Pythagoras, we can see that the hypotenuse is going to be the square root of 1 squared plus 1 squared, so that's just root 2. We can now use this to work out cos, sine or tan at any 45 degrees. Now for the 30 and the 60, we're going to draw an equilateral triangle. So all the angles are 60. We're going to make the sides equal to 2 on this one. Now if we split it in half down the middle, with a perpendicular line, we can now see that we would have 1 at the bottom, for the bottom of the right-hand part of the triangle, and we've got 30 degrees at the top. So we've created our 60, 30, 90 triangle. Again, by a quick bit of Pythagoras, we could see that the perpendicular height must be the square root of 2 squared from the hypotenuse minus the 1 squared at the bottom, which would give us root 3. So we can now use these to work out all of the values we need. So cos 30, looking at the bottom triangle there, so cos is adjacent over hypotenuse, so cos 30 is going to be root 3/2. From the top triangle, sine 45, so opposite over the hypotenuse, is going to be 1/√2. And going back to our bottom triangle again for tan 60, opposite over adjacent is going to equal root 3. We can now put these in, so we've got root 3/2 times by 1/√2 times by root 3, all squared. Let's do some simplifying here. We've got root 3 in a couple of places, they're multiplying together, so that's going to make 3. The denominators are 2 times root 2. If we square a fraction, we're going to square the top and we're going to square the bottom. So 3 squared is 9. On the bottom, the square of this denominator is going to be 2 squared, which is 4, multiplied by the square root 2 squared, which is just going to go back to 2 again. So we get a final answer of 9/8. If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.